Hi, it's Miss House. In this video, I'm going to go over the algebra that you need to be able to be successful with Section 3.1 of Math 120. Now, each time we have a section, I'll do my best to provide you with the background information, just a quick review of the kinds of things that you'll see within the section as you're working the problems. So the first thing is function notation. In function notation, we have f of x equals y. The input variable is this x. The name of the function is f. It can be any letter, always lowercase, and sometimes you'll see G and H. Those are very common. And this overall expression means the output value, we also know that as y. So when you have a function like f of x equals x squared plus 2x minus 4, the x squared plus 2x minus 4 is called the function rule. It tells you what you're going to do once you know the value of the x, the input value. Another thing that's important to know is that when we write an ordered pair in function notation, we will write it x input f of x output instead of xy. We'll start to use this notation, x f of x, input output. So here is an example of function evaluation. Given the function f of x equals x squared minus 2x plus 1, find f of 2. So f of 2 means that we will input the value 2 everywhere in the function where we have an x. Now my suggestion to you is to use parentheses when you do this. That's because you can make a lot of sign mistakes if you don't do this. So in this case, we have 2 squared minus 2 times 2 plus 1. So that's 4, subtract 4 plus 1, and our final value is 1. Now that's going to correspond to the ordered pair 2, 1 if we were to put this on a graph. Now we're going to find f of negative 1. F of negative 1 is negative 1 squared. Very important, we have the parentheses here. Okay? Subtract 2 times negative 1 plus 1. So negative 1 squared means negative 1 times negative 1, which is 1. A negative times a negative is a positive, 2, plus 1. So the answer would be 4. And that would correspond to the ordered pair negative 1, 4. Now let's talk about reading the graph of a function. So I've color-coded a few points here. I have f of 2 equals 0. That means at 2, see 1, 2, the output is 0. So y is 0 here, so that's the point 2, 0, which is what f of 2 equals 0 corresponds to. Find f of x equals 3. Okay, so f of x equals 3 here in yellow. Look, that means y is 3, right? Because f of x means the output value, which we used to call y. If it's 3, 1, 2, 3, here it's at 3. That's where x is 0. And here it's also at this 3 level. That's where x is 8. So we can say f of x equals 3 for x equals 0 and x equals 8. And lastly, we have f of 4 equals negative 2. So here's 4. That's our input, and our output is down here where y is negative 2. The next thing is we will need to know how to multiply binomials, which is an application of the distributive property, also known as the FOIL rule. That's a little rhyme or an acronym that we use to multiply binomials. Now, this only works for binomials. You've got two terms in your first binomial and two terms in your second binomial. So when we multiply, we do the first, that's the F, the outer, that's the O, the inner, that's the I, and the last, which is L. So in this case, we have x times x is x squared. X times negative 3 is minus 3x. The inside is plus 6 times x, that's our 6x. And then 6 times negative 3 would be a minus 18. Combining these like terms, we get a positive 3x, so our final answer is x squared plus 3x minus 18. Sometimes when we multiply binomials, the inner and the outer will cancel to 0. So when we do the first two, we get x squared. When we do the outer and the inner, we get a minus 4x and a plus 4x. And when we do the last two, we get a minus 16. So these two terms are opposites, so they add to 0. We're left with x squared minus 16. Now this is going to be true anytime you multiply conjugates. And conjugates are binomials that look alike, but the middle signs are different. So a plus b, a minus b. So x plus 4, x minus 4. And our last example of multiplying binomials is 2x plus 3 times 3x minus 2. So the first two is 6x squared, the outer 2 minus 4x, the inner 2 plus 9x, and the last 2 minus 6. Combining like terms, 6x squared plus 5x minus 6. Now we're going to talk about factoring a trinomial. So we're going to reverse the process of multiplication, okay? And that is we're going to come up with the two binomials after they've already been multiplied. Now to do this, to factor, we find numbers that multiply to get c, that's the constant or the last term, that also add to b, that's the coefficient of the second term. Now this is the format, x squared plus bx plus c. Now these exponents might be slightly different, but in general we'll mostly see a square here and a 1 here. If this is a 1, okay, leading coefficient means the first coefficient. If it's a 1, then all we have to do is look at the factors of c, find the pair that adds to b, and that's going to be our factorization. So, for example, x squared plus 5x plus 6. The factors of 6 that add to 5 are 2 and 3. 2 times 3 is 6. 2 plus 3 is 5. That means that our trinomial will factor x plus 2 times x plus 3. And of course, you can FOIL it to check it to make sure that you have the right answer. Now, please note that the order of the factors doesn't matter. Okay, so it's okay that you can put x plus 2x plus 3, or you can put x plus 3x plus 2. This order doesn't matter. The second example, x squared minus 8x plus 12. We need the factors, the numbers that multiply to give us 12. that will add to negative 8. So that's going to be a negative 2 and a negative 6, because negative 2 times negative 6 is positive 12. Negative 2 plus negative 6 is negative 8. So our factorization is x minus 2 times x minus 6 in either order. The last example of factoring a trinomial with a leading coefficient 1 is x squared plus 4x minus 32. Positive 8 times negative 4 is negative 32. Positive 8 plus negative 4 is 4. Our factorization would be x plus 8, x minus 2. And again, always check your FOIL rule to make sure that your binomials are correct, especially the signs. So now we're going to factor a trinomial that's a little more complicated. We're going to factor a trinomial where a is not 1, and we use what's called the AC method. Okay, so it's ax squared plus bx plus c instead of just x squared plus bx plus c. So there's going to be a number here that's not a 1. For example, 6x squared plus 7x minus 20. Now step 1, we're going to multiply a times c. So a is the coefficient of the x squared term and c is the constant. So a times c for this trinomial would be 6 times negative 20, which is negative 120. The factors of negative 120, that will give us the b coefficient. Okay, that's our step 2. Find the factors of a times c that add to b are going to be negative 8 times 15. And use your calculator to figure this out. Start with negative 120 divided by 2. Then divide it by 3 and 4 and 5. And keep going until you find the 2 that will add up to 15. Negative 8 times 15 is negative 120. Negative 8 plus 15 is 7. Now, unlike the trinomials where a was 1, we can't go straight to the factorization. We have to do step 3, which is split the b term into 2 terms. So instead of 7x, I'm going to put the minus 8x and the plus 15x. So I've split b into 2 terms, and now we have a polynomial with 4 terms. Okay, this is going to help us factor it. Now, to actually factor, we have to do step 4, which is to factor by grouping. We will do this whenever we have 4 terms like this. And in grouping, we mean we're going to look at the first 2 and take out their common factor. We're going to look at the last 2 and take out their common factor. And I always say, hey, drop this middle sign down so you don't lose it, okay? This sign in between the first 2 and the last 2 are going to be the sign of your second factor. So drop it down. So group, drop, group. So for the first 2, we just ignore the last 2 for a minute and look at the first 2. We look for the common factor of 6x squared minus 8x. That's going to be 2x. 2x times 3x gives me 6x squared, and 2x times negative 4 gives me negative 8x. So I've just reversed the distributive property. My sign is dropped. Now I'm going to group these two. 15x and 20 only have a 5 in common. 5 times 3x is 15x, and 5 times negative 4 is negative 20. Now notice that these 2 binomials now match, and that's very important. If they don't match, you have a problem. Either you picked the wrong numbers for these 2, or your trinomial was a prime trinomial that would not factor. If these don't match, you have a problem. Since they do match, now this is a common factor. 3x minus 4 is common to both. It gets factored to the front, and then this factor plus this factor is your second factor for the trinomial. So 3x minus 4 times 2x plus 5. And again, I highly recommend that you FOIL this out. 3x times 2x, 3x times 5, minus 4 times 2x, minus 4 times 5 to make sure it comes up to your original trinomial. Let's do one more of these. I'm going to multiply a times c because look, I have a 4 here. 4x squared minus 29x plus 30. And yeah, the numbers can get pretty big, but use your calculator to help you figure out these factors. So a times c is positive 120. The numbers that multiply for positive 120 and add to negative 29 are negative 5 and negative 24. And I have to admit, it took me a few tries before I found this. But I just went through my factors of 120. I was dividing 120 by any number that I could think of. And a lot of them didn't work. So divide by numbers from 1 to 60. So half of 120. You got to check. You just got to keep dividing. And then in your head or on your calculator, add those factors and see if they add up to negative 29. So for me, I found negative 5 times negative 24 is 120, and negative 5 plus negative 24 is negative 29. So I split my b term into minus 5x minus 24x. I factor the first two. They had an x in common. Left over 4x minus 5. Look how I dropped this sign down. Always drop your middle sign down. Take out a 6 from 24 and 30. That's a 6. That's going to give me a 4x because 6 times 4x is 24x, and 6 times negative 5 is positive 30. Look, once again, the binomials match. So I factor 4x minus 5 to the front, and x minus 6 is my second factor. Now let's talk about squaring a binomial. Whenever you see a binomial, that's a two-term polynomial squared, that means that you have to multiply it by itself. Do this by using the FOIL rule. X squared plus 2x plus 2x plus 4. Add your middle terms, x squared plus 4x plus 4. The biggest issue here is that x plus 2 squared is not x squared plus 4. And a lot of students will make the mistake of just squaring each term. But remember, this exponent means x plus 2 twice, and the way we multiply a binomial times itself or two binomials is you use the FOIL rule. Here's the second example, and we're going to need this particular binomial squared a good bit in a later lesson. X plus h squared means x plus h times x plus h. So it's x squared plus xh plus xh. Hx and xh are the same thing. It's like 2 times 3 is equal to 3 times 2. So put them in the same order, xh, plus the last is h squared. Now I see that I have two of these, so my final answer is x squared plus 2xh plus h squared. Now I highly recommend that at least for this one, you memorize what x plus h quantity squared is. X squared plus 2xh plus h squared. The next thing we're going to run into in section 3.1 is rationalizing. Actually, for us, it's going to be the numerator, but you're probably familiar with rationalizing the denominator. So you may be asked to rationalize a denominator or a numerator. I chose to start with the denominator first because this is the one that most students have already seen. Whenever you have a square root in the denominator, that's considered an irrational number in the denominator. So basically, rationalizing the denominator means get rid of square roots in denominators. It's a simple technique. All I'm going to do is I'm going to multiply this denominator times itself. When you multiply a square root times itself, you always get a perfect square. And so you'll always get the number that's inside. So the square root of 6 times the square root of 6 is going to be 6 because that's the square root of 36. Now remember, the rule for fractions is if you multiply the denominator times the square root of 6, you must also multiply the numerator times the square root of 6. That's a rule for fractions. Whatever you do to the numerator, you must do to the denominator. And you can only multiply or divide. You can't add or subtract to a numerator or denominator because if you do, you lose your value. So we get 2 times the square root of 6 over the square root of 36. And then this is a rational number. I call it an outside number because it's outside the square root. And this is outside of a square root. So we reduce that to 6 just like we would any fraction. 2 6 reduces to 1/3, and we don't have to write the 1. Now in the second example here, we're going to rationalize the numerator. The numerator has a square root in it. That means get rid of the square root in the numerator. So I'm going to do the same technique because it's going to get rid of that square root for me, because when I multiply a square root times itself, I get a perfect square, and it's going to be the number itself. So the square root of 6 times the square root of 6 is the square root of 36. 2 times the square root of 6 is 2 square root of 6. The square root of 36 is 6 over 2 square root of 6. And once again, 6 and 2 are rational numbers. They're outside numbers, so I can reduce those. 2 goes into 6, leaves me with a 3 numerator. So here we have a rational denominator, no square root in the denominator. And here we have a rational numerator, no square root in the numerator. Keeping with rationalizing denominators or numerators, I'm going to rationalize the denominator of 3 divided by 1 minus square root of 2. It doesn't have a rational denominator because I have a square root, and I have to get rid of the square root for it to be rational. Instead of multiplying by just the square root of 2, this time I have to multiply by the conjugate. Remember, we saw conjugates back when we were multiplying binomials. Conjugates look just alike except for the middle sign. So 1 minus the square root of 2 and 1 plus the square root of 2. Whatever I multiply the denominator by, I must also multiply the numerator by. Now in the numerator, I can distribute this, or I can just write it 3 times 1 plus the square root of 2. And I recommend that you just leave it like this. It makes the reducing easier because you'd have to factor that 3 out in order to reduce it anyway. Now, recall that when you multiply conjugates, the inner and the outer terms will cancel out. So you really only have to multiply the first 2 and the last 2. So I've got a 1 times 1 is 1, and a negative square root of 2 times a positive square root of 2 is the negative square root of 4. That's going to give me a plain 2. So my denominator is 1 minus 2, which becomes negative 1. So I'm just going to say 3 divided by negative 1 is negative 3, and then times 1 plus the square root of 2. You may distribute this or you may leave it, and I suggest that you just leave it as it is. Now we're going to rationalize the numerator. Here we have a square root and a numerator, and we want to get rid of that square root. I'm going to use the conjugate method again. I'm going to multiply the top and bottom of the fraction by the conjugate of 4 plus the square root of 3. That's going to be a 4 minus the square root of 3 on both the top and on the bottom. If I fold this, I'll see that the inner and the outer will cancel out, and I just have a 16 minus the square root of 9. On the denominator this time, I'm just going to leave it 6 times 4 minus the square root of 3. Reducing my numerator, the square root of 9 is 3, so I get 16 minus 3 is 13. And this is now over 6 times parentheses 4 minus the square root of 3. Now, since 6 will not divide evenly into 13, I'm finished, and this is my answer. It has a rational numerator because there are no square roots in my numerator. Now I'm going to simplify a complex fraction. Okay? When you have a complex fraction, that means you have a fraction that has more fractions inside. That's why it's called complex. There are more than one way to do this. You could get a common denominator and add these, but that's not the easiest way. What you want to do is you want to find your least common denominator, and you want to multiply the top and the bottom by the LCD. So I could say top times the LCD and the bottom times the LCD. Now, of course, when I do that, I'm going to have to distribute it to both terms, and down here just one term. Okay? To find the LCD, all you need to do is list all the denominators without duplication. So look, 2 is different from x, is different from x plus 2. So that means my LCD is going to be 2x times x plus 2. I list all the denominators in a multiplied form, and if something was duplicated, like there was another 2 down here, I would only need to write it once. But in this case, they're all unique, a 2 and an x and an x plus 2. Now, I'm going to multiply the top and bottom by 2x times x plus 2, which means it's going to get distributed times all. So what you see here is I've written the LCD 2x times x plus 2 here, 2x times x plus 2 here, and 2x times x plus 2 here. And what I'm going to do is I'm going to use the fact that any number divided into itself is 1 to reduce out the common factor. So in this first fraction, the x plus 2's will be eliminated. And that's great because I won't have a denominator anymore. In the second one, the 2 is going to get eliminated. That gets rid of that denominator. And of course, in the bottom, I don't have any denominator, so I'm just going to have to multiply this. So looking at what's left after I cancel out a negative 1 and a 2x, I get a negative 1 times 2x. Looking at what's left here, I get a 1 times x plus 2, so that's x times x plus 2. So now what I want to do is I want to multiply out this, okay, because multiplication comes before addition. So I got to multiply out. I get x squared plus 2x. And then I have negative 1 times 2x, which is negative 2x. My denominator, I just multiply the x times the 2x and get 2x squared. You could distribute this, but you probably don't want to. Factored form is best for reducing. So just leave the bottom unmultiplied and just write it in a little bit simplified. This x times this x is x squared. Now I have to see what happens here. You'll notice there's a minus 2x and a plus 2x, and those are opposites. So this minus 2x and this plus 2x are going to add to 0 and leave me with just an x squared. And here's why I like that I didn't multiply this out, because look, this is an x squared factor. This is an x squared factor. It's being multiplied. It's not being added. If it was added, I couldn't reduce it. But because this is being multiplied down here, that means a number divided by itself, and that's going to leave me with a 1 in my numerator. Now let's talk about expanding a binomial. Now I want you to look at all the work that goes into this expanding a binomial. I have x plus 5 to the fourth. And what we mean by expanding a binomial, it's a power of binomial. Okay? So x plus 5 to the fourth means I would have to write this out 4 times. Then what I chose to do is the first two to get this x squared plus 10x plus 25, and the last two to get another x squared plus 10x plus 25. Then I have to multiply this x times everything over here, that's x squared times that trinomial. And then the 10x times everything over here, so that's the 10x times everything in the second trinomial. And then the 25 times everything in the second trinomial. Then I've got a bunch of distributive that I have to do. X squared times x squared, x to the fourth. X squared times 10x is 10x to the third. X squared times 25 is 25x squared. 10x times x squared is 10x cubed. 10x times 10x is 100x squared. 10x times 25 is 250x. And then at the end, 25 times x squared, 25x squared. 25 times 10 is 250x. 25 times 25 is 625. I look all throughout this and combine like terms. There are no other x to the fourth, so that's there. I've got a 10x cubed and a 10x cubed. That's a 20x cubed. I've got a 25x squared, a 100x squared, and another 25x squared. That's 150x squared. There's a 250x and a 250x, which is 500x. And then there's a 625, and so that's the answer. Now, surely at this point you're thinking that's an awfully long process, and it is. And it could be even longer if I had something like 3x minus 2y to the seventh. Imagine I have to write that 7 times and multiply it. While it's not impossible, it's very improbable. And it's very, very likely that you would make a mistake. Okay, it's improbable that you would be able to do it without a mistake. I'm not even sure I could do it without a mistake. So instead of that, we have this thing called the binomial theorem. The binomial theorem, because this is just too messy. And while all of this may look complicated, it's really a lot faster than all of this. Okay, I have 3 lines here, 1, 2, 3, and over here I've got 1, 2, 3, 4, 5, 6, and a lot of multiplying. One of the things about the binomial theorem is that we have to find these coefficients first. You'll see these numbers in yellow. Now there is a formula for finding these, but the easiest way is to use this triangle, which is called Pascal's triangle. Okay, Pascal's triangle. And to do that, what we do is we start with a triangle of ones. We always have ones down this left diagonal and ones down the right diagonal. And to find the numbers in between, we simply add the 2 numbers above. So like here, I get a 1 plus a 3 is a 4. A 3 plus a 3 is a 6. A 3 plus a 1 is a 4. Now I stopped at this row because I have a 4th power, and what I need is the first time I see a 4. Okay, there's that 4. Okay, so that's going to be my 4th power row. So I've transferred 1, 4, 6, 4, 1, 1, 4, 6, 4, 1 down here as the coefficients of these numbers. Now, as for what we do with the x and the 5, the x starts at a power 4, x to the 4th, and then it goes down by 1 each time. So x to the 4th, x to the 3rd, x to the 2nd, x to the 1, x to the 0. The 5 starts at 5 to the 0, goes up 5 to the 1, 5 to the 2, 5 to the 3, 5 to the 4. Now, any number to the 0 power is 1. So 5 to the 0 is 1, and down here at the end, x to the 0 is 1. So the last thing I have to do is these powers of 5. 5 to the 1 is 5, 5 to the 2 is 25, 5 to the 3 is 125, and 5 to the 4 is 625. Now I'll multiply these together. 1 times x to the 4th times 1 gives me x to the fourth. Now remember, over here we had x to the fourth. For the second term, I multiply 4 times 5 is 20, x to the third. So just like here, 20x to the third. The third one, 6 times 25 is 150x squared, like we got here, 150x squared. 4 times 125 is 500 times x, just like we got here. And at the end, I have 1 times 625, which is what we got using the other method. Now, luckily for us, in this class, we're probably never going to do anything higher than a fourth power, so you can take the messy way. But if you'll practice this a few times, it will actually be shorter, and there's a less chance that you'll make a careless mistake with a sign. So that is the end of a quick review, or a lengthy review maybe, of the algebra that we're going to run into in section 3.1. Now, we're not going to have as much new algebra every time, so as we go along, I will try to do a review of this algebra for you so that you know what's coming. And then you can always go back to this video and refer to it if you run into that kind of algebra in a homework problem that's a calculus problem.